Hello there and welcome back. In this video, we are going to see how you can create a small cargo web application with the Axum uh, crate and the Tokio crate and how you can containerize it. So let's sip some coffee and get right into it. So basically, we want to use the cargo new web app command, and inside the web app directory, let me make it bigger a bit. We have to issue two commands. Cargo add Tokio features macros and RT multi thread. And we will also have to issue the cargo add Axum. If we did everything correctly and open our package, in the cargo toml file, we should see the Axum and the Tokio added. That's what we are going to need. And the web application is going to be pretty simple. So we will use Axum and we will need the response HTML and the routing get router. Get and the router. Oh, that's it basically. And we can decorate the function with Tokio main. And this is going to be the async fn main. And basically we will create our app instance from the router new. And then we are going to associate with it a route with the default context route, and the get is going to get us the handler, and we are going to say that that's it. After that, we can create our listener, and this is going to be the Tokio net TCP listener, and we are going to bind to the 0.0.0.0.8080. This is going to be our port. And we are going to have to use the await and unwrap. And we just simply say that we are listening on. Let's copy and paste it. Good. And Axum server listener and the app await unwrap. So technically that should be the main function, and the async fn handler is going to return an HTML and we say HTML h1 welcome to Rust. Let's close the tag. If we did everything correctly, we should be able to use the cargo build command. And HTML static str So what is the problem? H1. Oh, we have to return. So cargo build. Cargo serve. serve I knew the indentation is not going to be okay, so let's pull it up to the same line. Await, unwrap. Okay, cargo run and allow it. And if you open up a new Google Chrome browser and go to the HTTP localhost 8080, we should see that we are welcome to Rust. So now we basically know how we can create our own small web app in Rust. And the next thing that we want to do is containerize it. So I have a CentOS 10 machine prepared, and it has Docker. So first we are going to take a look at a simple Docker build, and then we are going to see the multi-stage build as to whether it reduces the size or not. So let's create a folder called Rusty, and in the Rusty folder we will need the main.rs and the Docker file. So the main.rs is going to be simple because all we have to do is to copy this and paste it, so we know that this is a working code. And in the Docker file, first we are going to use the, let's save it, make it a bit bigger. Okay, so from Rust we are going to run cargo new web app, and we are going to set the work directory to ./web app. So we are in the create folder, and we can use the cargo add Tokio features macros and RT multi thread, and we can use the cargo add Axum, and then we can use the run cargo build -- release. So this is going to be the most optimized version, and at the end of the day we can use the CMD to run our application, and it should be in the target release and web app. So let's save it and use the docker build -t reaper fat, and technically this is going to be the first that we build. Okay. Recently the internet speed starts to get really slow after around 5 p.m. or I don't know what's with the service provider, but for now, if it pulls down the initial layers, we should be good to go. So it has added, we are building the release. Good. And the docker run reaper fat and -it -p 8080. So now we have the hello world. Docker ps. What? This is not how it's supposed to go. So Docker file, and we have the target release and the web app. Oh, hold on. I forgot to copy the main.rs to the src main.rs. Let's rebuild it. I said let's rebuild it. So now it should be able to go faster. It's in the last step. Good. Now let's run it. And we are listening. So just to verify it, let's go here and see URL http localhost 8080, and we are good. So this is a Dockerized Rust application. And Docker kill 1E9. Good. So the next thing that we want to see is the Docker image ls. And as you can see, it's 1.6 gigabytes, which is, let's say, kind of not so small. And we want to try out the multi-stage build. So basically what we want to do is to call this as builder. And we have the build command, which is the last one, which is supposed to run in this container. And then what we can do is to use the from Rust slim, and we basically want to copy from builder and dot web app target release web app to the current web app file, and then we can use the cmd // web app. Now let's build the slim version. From casing as from QoS casing do not match. What? From Rust as builder. Oh, it should be capital. Okay, now we can check the docker run -it -p 8080 8080 slim, and it's still expected to work because the code didn't change and we got the response. But let's see the image. So docker ps docker kill e8. Good. So docker image ls should be the command. And as you can see, the slim is half the size. And I think that's a pretty considerable gain for the image. And one thing I can do is to search for the slimmest Rust image for Docker. The smallest Docker image, Reddit, Rust. Yeah, IoT, fully Rust, smallest size. Very small Rust Docker image. Alpine. How to build a very small Docker image. Resulting image for Hello World was 6 megabytes. Okay. And mini size Rust. What's the Docker file? Rust Alpine. Let's see the Docker hub. Docker.com. Rust, and maybe we can have some gains. Rust Alpine is the one that he used. Alpine, Epic, glibc. Set the binary as endpoint. And libgcc is needed. Let's try it. Let's copy Docker file to Docker file Alpine. And let's use the Docker file Alpine. So technically, how old is it? Let's check the Alpine. Yeah. Oh, that's 3.21.3. Well, let's just use the latest. Let's try it. So from Alpine latest, and we need to run the apkg to add the library, and then we copy and execute. Good. We don't need the double one. Let's save it and docker build -t reaper pi slimmest and docker file _ alpine. What? Docker build and --help. So file, name of the Docker file. Let's use this -f. Docker build x requires 1 argument. What? Docker build -t, that's the tag. -f is the file. Okay. And then we are going to move the Docker file Alpine to Docker file. And we rebuild it. Docker build. And dot. Maybe. Docker image ls. Oh my god, that's 8 megabytes. So docker run -it -p 8080 8080, and we specify the slimmest. .webup, no such file or directory. AI docker file and copy from builder. But why did it not execute? Copy from. Let's try it this way. Docker file and from? And we say that this is going to be it. Okay. Why can it not find it? Let's try it this way. Rebuild it slimmest and run it. But it has it. CMD / web app. Let's see what ChatGPT has to offer. ChatGPT OpenAI. I have the following Docker file. Yeah. No, that's not the problem. The problem is the Docker run and no such file or directory. That's the problem. Aren't available. Then let's swap it out. So it is not that the web app is missing, but rather the library it depends on. Let's remove this one. And let's rebuild it. Good. Now it needs some Debian images. glibc not found required by, and that's the problem. So now, if we want to install it, we are going to need this. Let's go with the Docker file. And rebuild it. So glibc libraries come from the CA certificates package. Interesting. That's still an issue. Let's see what ChatGPT has to offer. I think it's just the development header. This is a common issue when building on one system and running the binary on other system that lacks the exact glibc version. I see. So, maybe reduce the size, strip symbols in cargo. This will give a portable circuit that doesn't require glibc. So let's try to edit the Docker file. Maybe we are learning something new. So vi cargo.toml And here, this is going to be 1, and the Docker file, and Alpine latest. And we have to copy the cargo.toml to the cargo.toml, and then we can add the dependencies. That should be good. And we remove this part. Let's rebuild it. I said let's rebuild it. Good. So relative path. Oh, we have cargo Tokio failed manifest caused by missing either a package or workspace. Yeah, I know what's the problem. We need this one as well. And let's add the dependencies too. So cargo.toml, and let's add it here. Okay, let's rebuild it, because we have created a new project and overwrote the cargo.toml file without adding the necessary information, which was added by the cargo create. So, oh, it is taking longer. Good, 2 warning. Good, and let's run it. And Docker image ls. That's the slimmest. And we have built it successfully. And if you run the bin bash, it will not work. But here we have the web app. Ooh, ls-larth. It's 1 megabytes. pwd. Web app. Let's see what the ChatGPT has to say about this error. It is starting to turn into like the binary depends on dynamic libraries that are missing or incompatible. LLD. Ooh. No such file. So double check your build. Stop target add. That's the muscle package. Let's try it. So Docker file, and that's the work directory, and before the work directory we have to say this one, and they made the run chmod +x web app, and let's rebuild it. This is going to be the last try. Downloading for x86 unknown Linux. We are learning something new every time. Hyper Axum compiling. Oh, so the target is going to set Rust, so it is going to download every library which may be needed. No. What is it? LLD web app. LDD. So no such file or directory. Cargo build release and let's Docker file, and we are going to target this one. Let's do the build. And what is it? Let's Google it. Rust GCC. Oh, this is the target that you can specify when you are creating your release. Haha. Okay. Copy from. So what I think the problem is that now it has a different name. Let's try this one. So cat docker file, and we are going to use the Rust up on our own machine. No, we don't need you to listen. So let's copy and paste it. That's not really going to work, I think. Let's exit it. And we insert it here. Downloading components for Rust std. Okay. And we will need the command that was issued. So this was the command. Oh, the ventilators of the PC spin up. CC not found. There. Target. Release. How do we solve this? Linker not found. Or maybe I should just try and link it. I have an idea. Docker file. Let's save it to the notepad. And then this is all we are going to do. Docker build, slimmest, and Docker run, bin sh, ls the shell target, ls dash l target, release, and build. No. Where did it put the file? x86 unknown muscle. And then the release. And the web app. So this is what we need to use. Vi docker. And let's paste it here. We need the rest. And yeah. Let's copy this. And this is gonna be the target and the release. Let's delete it and rebuild it. So that's gonna be the slimmest. Okay. And LDD web app. Ho. So let's try to run it. And it is working. So I think let's just try to SSH CentOS 10 sudo systemctl stop firewall d and curl http localhost 8080, and it's working. So lessons learned. The video became longer than I expected, but 7CA, we are now able to build self-contained Rust-based containers. And this target platform will take care of building it, so it includes everything that is needed for a 64-bit Linux version. So that was all I wanted to show you in this video. See you in the next one.